Good morning, students. Chapter 8, Gravitation. In last lecture we have discussed about gravitational acceleration and acceleration due to gravity of Earth above the surface of Earth. In this lecture we will see acceleration due to gravity below the surface of Earth. Okay, see here. It is Earth. Okay. Yes, it is center of Earth. Clear? Okay. Now, acceleration due to gravity below the surface of Earth means it is surface. It is surface, and we want to find acceleration due to gravity below the surface of Earth. So I will assume one point. Suppose I want to find acceleration at this point. Okay, if at this point one object having mass m is placed, and what is its acceleration? Clear? Distance from center of this particle is r. Okay, and depth from surface is d. Depth from surface is d. Do you understand question? Okay, we want to find gravitational acceleration at a point below the surface of Earth at depth d. Okay, take a point mass m below the surface of Earth at depth d. At depth d, and r is distance from center. We know that what is radius of Earth? It is r. What is radius of Earth? It is r. So understand what is the relation between them. RT is equal to d plus r. So r, distance from center, distance of object from center, r is equal to, this r is equal to, obviously it is re minus d. It is re minus d. Clear about this? So first of all, take one point mass m below the surface of Earth at depth d. Distance of object from center is r is equal to, it is re minus d. Okay. Now see, in last theory there was acceleration due to gravity outside. So object was outside of the whole Earth or of all spherical shells that we have assumed. Okay, but in this case object is inside Earth. So what happens here? We have to assume okay, this whole Earth is made up of two parts. Which two parts? See, first, a sphere of radius smaller, like this. A sphere of radius smaller. A sphere of radius smaller. Okay, a sphere of radius smaller. And second, a shell. A shell of thickness d. 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 Okay, yes, it is a shell of thickness d. See here, it is a shell of thickness. Okay, can assume that Earth is made up of two parts. First, a sphere of radius r and a shell of thickness d. And this point is here. This point means this mass point is here. It is here, having its mass. Clear about this? Hello? Clear about this? Okay. So now what happens? See here, we can imagine Earth to be made up of first sphere of radius r and second spherical shell of thickness d. Spherical shell of thickness d. Okay, so now at this point we will find gravitational acceleration due to these two. We know that if you are given spherical shell and point is inside, yes, if you are given a spherical shell and point is inside, then on that point force is 0. Yes, you know that. Okay, we know that due to spherical shell of thickness d, due to spherical shell of thickness d, as point is inside shell, force is 0. Force is 0. Simple. One simple statement. See, this point is inside this spherical shell. This point is inside this spherical shell. It is spherical shell, and this point is here, and this point is here. Sorry, orange out. Okay, this point is here. Means we can say that this point is inside this spherical shell. Okay, so due to this spherical shell, force is 0. Due to spherical shell of thickness d, as point is inside shell, force is 0. So on this point, force is acting only due to sphere of radius r. Okay, at depth d on point, force is acting only due to sphere of radius r, because point is on outer surface of sphere. Point is on outer surface of sphere. Clear? Okay? Okay, man? Yes. So yes, at this point, now we have to find gravitational acceleration due to this part of Earth only. Due to this part of Earth only. Because due to this big part, that is spherical shell, due to this gravitational forces. Clear? Now, see here, this part of Earth, it is part of Earth, not the whole Earth. Okay, so we know that ME, that is mass of whole Earth, RE, that is radius of whole Earth. Yes or no? So is mass of this part is ME? No. Okay, first of all we have to find what is mass of this part, means what is mass of this sphere. How to find? See, here I will write for the whole Earth. Okay, its density. Density rho is equal to, it is mass upon volume. Mass of Earth, we write mass of Earth as ME, and volume means is 4/3 pi RE cube. Mass is equal to m and volume is equal to this 4 by 3 pi RE. So I can write rho is equal to it is 3 m upon 4 pi RE. Okay. Now we have to find gravitational force or gravitational acceleration only due to this sphere. So therefore mass of remember, okay, mass of sphere of radius r, that is me dash. Why me dash? Me is mass of whole earth, me dash is mass of only this part. Me dash is mass of only this part. So me dash is equal to, remember chapter number 7, for one dimensional object dn is equal to lambda dx. For two dimensional object dn is equal to sigma dA. For three dimensional object dm is equal to rho dv. Okay, so therefore me dash is equal to, it is rho dv is equal to rho. What is rho? It is 3 me upon 4 pi RE cube. dv means volume of this sphere, and it is 4 by 3 pi R cube. So 4 cut, 3 cut, 3 cut, 5 cut, 5 cut. Okay, so therefore me dash is equal to, it is me R cube upon R cube. me R cube upon R cube. Any doubt? So yes, mass of this sphere is me dash, and me dash is equal to, it is me R cube upon R cube. Any doubt? Any doubt? Sure? Okay, so as this point is outside this sphere, we know that what is equation of gravitational acceleration? See, as point is outside sphere of radius r, gravitational acceleration at this point GD. Why I am writing GD? Because it is at that. GD is equal to, how to write equation? G me dash upon r square. Yes, it is equation of gravitational acceleration actually. Yes or no? G me dash upon r square. Why me dash? Because at this point gravitational force is only due to this part. So it is GT is equal to G me dash upon r square. Okay, now put value of where is yes, put value of me dash, that is here. Okay, so is equal to, it is G upon r square. What is me dash? It is me r cube upon r cube. So r square cut, here it is only 1 r. Any doubt? Hello? Any doubt? Okay. So therefore GP is equal to, it is G me r upon r. Simple. I can write this equation as, see, here is equal to G me r upon this r cube. I can write like this. It is r square into r. Yes or no? Yes, I can write r square into r. So see, what is this? G me upon r square. This G me upon r square is nothing but G. Yes, G me upon r square is nothing but G. So therefore GB is equal to, it is GE r upon r. GE r upon I. And therefore this GB is equal to, yes, one equation you have to remember this. Another equation, GD is equal to, it is GE r is equal to I minus E. So here it is RE minus V upon I. So is equal to it is GE RE upon I, it is 1 minus D upon I, it is D upon I. Okay, so yes, you have to remember this equation also. It is GE 1 minus D upon clear GE, that is GE, gravitational acceleration surface of Earth, R, that is distance from center, RE radius of Earth, and this equation is in terms of depth. Okay, if you are given to find gravitational at depth 100 kilometer, so yes, you have to put value of D, that is 100, simple, clear? Okay, so it is how to find gravitational acceleration below. Why this one is difficult? Because in previous theory there was gravitational acceleration outside forces acting due to whole Earth. For outside case, forces acting due to whole Earth, so we have to consider its mass, that is ME, known. But here in this case, at this point, forces acting, gravitational acceleration is produced due to this part of Earth only, so we have to consider its mass. Clear? Okay, yes, you have to remember this equation. You have to remember this equation. And now, see, here, from this we will make some conclusion. Okay, we will make some conclusion. Which type of conclusion? See, here, yes, this equation, GE is equal to, if I multiply GE inside, then it is GE minus D upon RE GE. So therefore, GE minus GE upon GE is equal to minus D upon I, is equal to minus D upon I. So again, as we move inside, what is meaning of this? As we move inside, if from the surface I am going inside towards center, gravitational acceleration decreases. Gravitational acceleration decreases. Clear? Okay, so yes, this equation you also have to remember. Okay, as depth increases, yes, if I am moving from this point, then depth increases, gravitational acceleration decreases. Okay, if depth increases, gravitational acceleration decreases. Clear about this? Clear about this? Okay? Okay, so it is one whole theory which is named acceleration due to gravity below the surface of Earth. And yes, you have to remember equations. You have to remember equations. GE 1 minus D upon I. Okay? Okay. Now we will see conclusion of these two theories. See, here it is. Earth. Yes, it is Earth. Okay, it is its center. It is its center. Sorry, it is its center. Okay, its radius is R that we know. First, if point is outside means R greater than I, then what is equation of acceleration? That is GH is equal to, it is G me upon R square. So we know that GH is proportional to 1 upon R square. Means as distance increases, gravitational acceleration decreases. Okay. Second, inside. Yes, inside. So in case of inside, what is GH? GD. So GD is equal to, we have proved it is GMER upon it is RE, or you can write it as GE R upon I. GE constant, RE constant. So here we can write one relation, that is GD is proportional to R. Is proportional to R. So as distance from center increases, gravitational acceleration increases. Okay? On surface of Earth, on surface of Earth, simply you have to write R is equal to I. So if you put R is equal to RE in this equation, it is GME upon RE square. If you put R is equal to RE in this equation, it is GME upon RE square. So therefore GE is equal to, it is GME upon RE square. Simple. GE is equal to, it is GME upon RE square. Clear? So yes, these equations you have to remember. These equations you have to remember. Okay? Okay? Okay then? Yes, it is okay. In this case, small r is equal to, it is RE plus H. In this case, small r is equal to, it is RE minus. Okay? Now we will plot one graph between gravitational acceleration and distance from center. Gravitational acceleration, distance from center. Distance from center. See, first of all we will take inside. Here I will mention, here it is R is equal to RE, means radius of Earth. So it is called inside Earth. Okay, and it is called outside Earth. It is called outside Earth. So chalo, inside, first of all for inside, GD is equal to, it is GE R upon I. R, that is distance from center. If point is at center means this R is equal to 0 and R is equal to 0, then GD is also 0. So yes, at center, gravitational acceleration is 0. At center, gravitational acceleration is 0. Now, GE R upon I, gravitational acceleration is directly proportional to R. So as distance increases, gravitational acceleration increases, and as it is directly proportional relation, here it is, G is proportional to R, it will be a straight line. It will be a straight line. On the surface of Earth, its value is G. Its value is G. After that means here I can say it is R less than RE, and here I can say R greater than RE. R greater than RE. So for R greater than RE, R greater than RE means this equation. GH and R, they are inversely proportional. So as R increases, GH decreases. But the relation is of inverse square law. So that graph is like this. That graph is like this. Okay? Here G is proportional to R. Here G is proportional to 1 upon R square. And yes, here it is gravitational acceleration on surface of Earth. So if we move from surface of Earth, outside or inside, gravitational acceleration decreases. Yes or no? See, it depends with respect to which you are observing, from center or from surface. Okay, if you say if from surface, so if from surface we are moving above or below, gravitational acceleration decreases. If from surface above or below, G decreases. G decreases. Okay, but with respect to center of Earth, first of all increases, becomes maximum, and then decreases. Clear? So statement, it depends with respect to which you are observing. Okay, so yes, these equations and this graph for gravitational acceleration versus distance from center, that you have to remember. Okay, so yes, with this is it for today.